Chapter 9, this is the review for test number 1. So these first two slides help you remember about vertex form, which is the main emphasis of this test. For quadratics is vertex form and how the parabola shifts left or right, up or down, and what the a value does. And then also the width, the a value deals with the width, meaning wider or narrower. So you may want to pause the video and review those ideas first and then restart the video and continue. So when we describe how these differ, these functions, these quadratic differ from the parent function y equals x squared always sits here at 0, 0. It opens up, and it's kind of what we would say a normal width. Okay? When you vary that in vertex form, this number inside the parenthesis shifts it left or right, and it's opposite of what you think. So this parabola would be shifting to the left 8. And it is not going up or down at all because we don't have anything, a k value right here. So it's just left 8. On the other hand, this next quadratic doesn't have anything in parentheses squared. It would be kind of like having x minus 0 squared, okay? But this minus 9 is shifting it up or down, exactly what you think. So this one is going down 9. And then you can use those ideas to actually graph where the vertex will be. In this next example, don't forget about this negative out in front. Always look for a negative. When there's a negative, it's going to flip it upside down. So this one's going to be flipped. There is no shifting left or right because there's no parenthesis. There's no number inside the parenthesis. If it was, it would be 0. But the plus 3 moves it up 3. Okay, so now we have multiple things going on in this next one. And so for this next one, the plus, there's no negative out front, but the plus 1, again, opposite of what you think, plus 1 moves it left 1, and minus 2 moves it down 2. And then this last one that we'll take a look at here, this 3 is a positive number right here. So it's not going to flip it, but what it's going to do is it's going to make it more narrow. Because instead of going up like 1, up 1 over 1, a little bit like slope, up 1 over 1, this is going up 3 over 1, so it's getting more narrow. Okay, the number inside minus 1 is going to move it right 1 and down 7. All right, so that takes care of sort of some transformations. You try this next. You try these next 4 right here, stop the video, get as far as you can, and then restart the video, and I will explain what the transformations are. So on this first one right here, this negative is going to flip it, and plus 2 shifts it to the left 2, and plus 3 is going to move it up 3. So you can see if you got that one correct. Moving on, this 4 right here is positive, so it's not flipping it over, but instead it's going up 4 over 1, or it's going to be more narrow. So we say it's narrower. Plus 5 is moving it left 5, and minus 6 is down 6. Okay, moving on to the next one. What you should have for this one is now it's 0.5, it's a number less than 1, so it's going up. 0.5 would be the same as 1/2, so it's going up 1 over 2, it's getting wider. And then the plus 2 again is shifting it left 2. And last but not least, this last one has lots of stuff going on. The negative right here is going to flip it. And the 2 part of it is making it narrower because it's going up at a faster rate than 1. It's going up by 2. So it's going to be narrower. And then the plus 10, again, is moving it left 10 and down 4. All right, so Now let's see if we can kind of do the opposite skill. We're going to pick out the vertex and put it down into an equation. Write the equation for it, rather than look at the equation and see how it shifts. So it says, state the vertex for each graph and write the equation for each function graphed below, using either one of these two formulas. And really, it's just that it's either going to be a positive one or a negative one for your a value. We are not going to write equations with widths other than 1 or negative 1. So if I state the vertex right here, that vertex is -1, -3. So now when I put it into the function notation, it would be f of x equals, it's opening up, so it's just going to be a 1 in front for a, and then I'm going to have x minus a -1 squared plus -3. Or we usually fix those signs, and we don't really need the 1 in there, so it'd be x plus 1 squared minus 3. And again, many of you have noticed that whatever your vertex is, the x value, when you put it in the parenthesis, it's the opposite. Or if it's +1, it comes out as -1. Some of you started to notice that, but you can just put it in and fix the signs. And then the domain is all the x values. And the domain for all these quadratics are going to be all real numbers. It's the range that varies, and the range are your y values. And my y values never go lower than this point, which happens to be the same as your vertex. So my y values never go lower than -3, so that means they're greater than or equal to -3. Okay, let's try the second one. Again, I will try this one with you. You may want to pause the video, though, if you're ready, and try it on your own. All right, this vertex right here is the ordered pair 2, -1. So again, going up here, it's flipped over, so now we are going to have this negative with it. So I am going to write my equation, f of x equals, this time I'm going to have a negative in front, because it's -1, and then we'd have x minus 2 squared plus -1. Again, fixing those signs, you wouldn't really need the -1, you could just have a negative. If you want the 1, that's fine. So x minus 2 squared plus a -1 would just be -1. And then my domain, again, is all real numbers, and my range is my y values never go above that y value of -1. So my y values compared to -1 are always less than or equal to. Okay, you try number 3. Pause the video and then either check the notes or restart the video for the explanation. All right, so over here we have 1, 2, 3, 4, 5. We have the vertex is -5, 1. And so now we are going to, this is a positive, it opens up, so we're going to use this equation right here. So f of x equals x minus a -5 squared plus 1. And again, fixing those signs, you would have x plus 5 squared plus 1. Again, notice, some of you are noticing that when your vertex is -5 for the x, in the parentheses, it's the opposite, it's +5. And that's just from fixing the signs. Your domain is all real numbers, and your range are the y values, and your y values never go below 1, so your y values compared to 1 are greater than or equal to. Okay, so now let's get into graphing these. Again, this test is going to be heavy on the vertex form. You're going to be doing all the things we just did previously as well as graph. So when we graph these, the first thing we're going to do is notice the transformations. Okay, this right here is flipping it, so we should expect it to open down. And then it's going to the left 1, and it's going down 3. So our vertex, if it was supposed to be at 0, 0 for f of x equals x squared, then if I shift it left 1 and down 3, there's my vertex. Okay, so you really don't even need to like think about the equation and how to pick out the vertex. You can actually just do the shifts. But again, if we look at the equation, notice that this is plus 1, so our vertex is going to be the opposite of that, or negative 1. It flips it. Okay, remember how we talked about in those last examples. And then the y value is minus 3. I put that vertex in the middle of my table. Okay, so then what I do is I'm going to add ordered pairs to my table that are larger than negative 1 and smaller. So smaller would be negative 2 and negative 3. Larger would be 0 and 1. So then what I do is I take the 1 for x, I plug the x value, I plug all of these x values right here in for x. So I'm going to write that out, that it's going to look like f of x. You could put f of 1 in there. That's what we did earlier in the year. But we have minus, and then we have our x value that we're putting in as 1, and then we have plus 1 squared, and then we have minus 3. Now, if you type that all into your calculator exactly like you see it, that's all you need to do. Otherwise, you have to take the opposite of 1 plus 1, which is 2 squared, minus 3, which would be the opposite of 2 squared, or 4, minus 3, which gives you negative 7. Okay? So then I can graph. I like to graph these as I go. So I would get 1, negative 7, which is right here. And now I'm going to put 0 in there. So I'm doing the same thing. Equals the opposite of 0 plus 1 squared minus 3. That's 1 squared, or 1. So you get negative 1 minus 3. You should get negative 4. So again, on your calculator. Okay? When you plug in negative 2, okay? F of negative 2. Again, it looks like this. The opposite of negative 2 plus 1 squared minus 3. Okay, so again, just simplify all of that on your calculator, and that should also give you negative 4. Put your negative 3 in there, calculate it out, and that will also give you negative 7. So I am going to graph these other points, and you can see they match up across the axis of symmetry, and so there is your graph. Okay, again, your domain is all real numbers. And your range is the y values, and the y values never go above that y value of your vertex, so my y values are going to be less than or equal to negative 3. All right. Oh, we forgot to put the vertex listed here. Sorry about that. I kind of skipped this. So it'd be negative 1, negative 3. I did put it in the table, though. All right, let's go on to the last one, I believe, and that is graphing in standard form. So first of all, we should probably review that standard form looks different. It's f of x, or that's the same as your y, equals ax squared plus bx plus c. Okay? Your y-intercept is always your c value. So in this case, my y-intercept is 16. My axis symmetry is always the equation of the line x equals the opposite of b divided by 2a. So in this case, we would have the opposite of b, which is negative 10, so that makes it positive 10, over 2 times 1. And that gives us 10 divided by 2, so our axis symmetry is x equals 5. You do need that x equals part. So my axis symmetry is x equals 5. It's a line that goes through the x-axis at 5, okay? And so my vertex is on that line. So the x value of my vertex is the same x as my axis of symmetry. So now what I need to do is I need to find the y value for my vertex. And I find the y value for the vertex kind of the same way I did for graphing the last one. I take the value of x and I plug it in for x to the equation to find the y value when x equals 5. So that would look like this. F of 5, or the value of the function when x equals 5, is 5 squared minus 10 times 5 plus 16, and again, entering that into your calculator, make sure you can use your calculator accurately, will give you 16, we got 25 minus 50 would give us negative 25, plus 16 gives us negative 9. So our vertex is at 5, negative 9. 1, 2, 3, 4, 5, 6, 7. And these are going by 4s, which is kind of unusual, so be careful. I can plot my y-intercept, and that is at 16. So 4, 8, 12, that's way up here. Remember, I have another free point by going 1, 2, 3, 4, 5 spaces away from the axis of symmetry, but on the other side. So 1, 2, 3, 4, 5, I can reflect that over the axis of symmetry. But I only have 3 points and I need 5. So that's where the x-intercepts come in. Okay, the x-intercepts are the values of x right here when the y equals 0. So what I'm going to do is I am going to put 0 in for my y, or my function, and I'm going to set it equal to x squared minus 10x plus 16. Okay, I'm going to factor it. Means I'm going to find two things that multiply together that equal x squared minus 10x plus 16. I look for a greatest common factor. I don't have one. When I have this type, where the a value is 1, then I can look for two numbers that multiply to 16 and that add to negative 10. So I just start guessing and checking. Well, 4 times 4 is 16, but that adds up to 8 or negative 8. So that's not going to work. So how about 8 times 2? That's 16, but that adds up to 10. But I need it to add up to negative 10. So what if it was negative 8 and negative 2? That would still multiply to positive 16 and add up to negative 10. So those are my numbers that are going to go into my parentheses with the x values. So I have x minus 8 times x minus 2, and that equals 0. So here's where I use the zero product property. And if two things multiplied together right here have an answer of 0, then one of these two pieces has to be 0. So either this has to equal 0 or this has to equal 0. Can you figure out what value of x that you would put in to make x minus 8 equal 0? And that would be the value of 8. Because 8 minus 8 is 0, and 0 times 8 minus 2 is negative 10, but 0 times negative 10 is still 0. And the other value of x that you would put in here to make that parenthesis equal to 0 is 2. So my x-intercepts are 8 and 2. So I can plot those points. So here's my value of 2, and here's 4, 5, 6, 7, and here is my other value. And now I actually have all 5 points, so I can draw in my graph. So that is a good review. If you can do all of these questions, you should be successful on the test. And you may even want to try some of these again and make sure you can get them correct without my help. That's the end of our review for the test.